Hello, hello. Hi. How you doing? Today, let's see if I can get a, oh, there we go. There's a nice profile. Oh, we're going to make a virus. And it's the place where we're going to be playing for at least the next week, maybe more. And it was Josh and I that came up with this drawing that we're about to do. So, see if you can follow this. We're going to do it without a proof. We're just going to make the thing. So here we go. Start with a circle. And you make a diameter. So in Sketchpad, you select 2 points and construct a line. Then you construct perpendicular to that line. Then you want a radius that's perpendicular to that diameter. So there you go. While that radius is selected, construct the midpoint. Now construct the segment from 3 o'clock to that midpoint. And now click in a clear spot and select the 3 vertices of this angle and construct its angle bisector. How weird is that? Mark where the angle bisector hits your original diameter and construct a perpendicular right there. Believe it or not, here, let me show you. This is actually the start of your pentagon right here. Ba-boom and ba-boom. Let me verify for you that we've actually started our pentagon. Pentagon has all 5 sides the same, and the vertex angles are 108 degrees each. Let's measure this angle. It's 108. Yay! So it's definitely the right thing. Now, to get the other 5 sides, what we do is click on that angle bisector and its endpoint, construct a perpendicular, and where that crosses our original diameter, we construct a perpendicular there. Construct that perpendicular, and believe it or not, this segment from where that perpendicular hits the circle in both places, that's actually a side of our pentagon. So completing to here. You can do this yourself and measure these angles. They're all 108. We have a regular pentagon in the thing. Now here's what I like to do in Sketchpad is just hide these construction marks that I don't need. I don't need that. I certainly don't need that. I don't need this. I don't need this. I don't need that little dude. So we're just going to display hide them. And now I've got a fairly clean pentagon. Now we're going to make an elliptical pentagon. So honest to God, this actually works. You put the circle maker centered there, go to, my fault. Circle maker centered at a vertex and go to the opposite side. See how that arc is inside of your circle? That's the one you want. So we come over here and we go to the opposite side. And we come over here and we go to the opposite side. And we come over here and we go to the opposite side. And there's one more. Now, each of these little dudes, each of these circles we just made, are going to be elliptical lines, but I need to draw the correct boundary circle so that they will be elliptic lines. The boundary circle has to go through antipodal points. Or sorry, the boundary circle has to fix it so that the line goes through antipodal points. There's the spot right there. Because check out this circle right here. I'm going to emphasize it by turning it blue or turning it red. That circle hits that diameter up there, and it'll also hit down here. Let's see, is that the circle I want? That is not the circle I want. Hang on. I want the circle that goes, this is the circle I want. That's the one I want. Display color red. This circle will hit here and right down below, down here, and those will be antipodal points because I could extend that diameter right through. So that's the right size to make. This is going to be the center of our disk right here. I'll call it 0.0. And this circle right here is going to be the boundary of elliptical space. Display color, let's make it black to emphasize that it's extremely important. All right, so let's see. That means that anything that I say is an elliptical line has to go through antipodal points on this black circle. So check it out. I'm just going to draw one segment from where this circle crosses the black circle and down over there, and check it out. It goes right across O. That diameter goes right across O. Isn't that nice? That, ladies and gentlemen, right there is visual proof that we have the right size boundary. I don't want this. I'm going to undo that segment. I don't need it. So, believe it or not, this little arc inside of here completes an elliptical triangle, all of whose angles are 72. The elliptical angles are 72. Let me emphasize what I'm talking about here. From, stop it, there we go. Let's do another one. All right, now I'm going to show you the elliptical triangle that I'm babbling about. It's the elliptical triangle OBC. But let me shade it so you can see it. Stop that. So excited. All right, construct polygon interior. And this shaded guy is an elliptical triangle. And Josh and I have already done the proof. Each angle is 72 degrees, which is what we want. If we're going to model a virus, we need a bunch of 72-degree angles. Each angle in this thing is 72 degrees. So that's pretty cool. That's some pretty cool stuff. Now, check this out. You won't believe this. The next thing you do is extend the sides of the pentagon. I'm going to do it just one time. Extend this side, construct ray. And where the extended sides hit, use that, and you can see it hit some other lines too. Almost didn't have to extend the sides, but this is where the extended sides hit each other. I'm going to come back to that point as the center, and I want to go to the side opposite again, only not the side opposite, the diagonal opposite that skips a vertex. So I'm going to go to point B and draw the following circle. Check it out. Construct this circle. That is an elliptic line. Check it out. It's going through antipodal points. Let me mark this thing as, let's call it orange. This guy's orange. I hope you can see a different color there. It looks about the same color to me. When I go to do antipodal points, it's going to go from there all the way over to here. Oh, that's antipodal points. And if I make that segment is going to cross right across O. And it does. Very nice. So that's an elliptic line. And here's the cool part. This angle, I'll show it to you. I'm just going to draw it. This angle right here from this elliptical line all the way over to here, I guarantee you, 72 degrees. So we can use this to tile the entire circle with 72-degree triangles that are three angles of 72 each. Let me show you the finished product if you do all this stuff.